Okay, this is handout 2, experimental and theoretical probability. So I think on your paper, this part right here is kind of darked out. This should say experimental, and this one should say theoretical. So this one is experimental, this is theoretical. So again, as always, just pause the video when you need time to catch up. Okay, so here we go with our notes. Experimental probability is the ratio of the number of times an event occurs to the total number of trials. The question you kind of ask in experimental probability is what does happen? Think of this as a lot of like science class. You're performing an experiment. So experimental probability is the ratio of the number of times an event occurs to the total number of tries. An experiment is you're actually going to do it. Theoretical probability is the probability of an event happening based on the possible outcome. This is what should happen. What should happen. Experimental probability is what does happen. Theoretical is what should happen. So let's look at this spinner. It says, what is the theoretical probability of spinning a section with stripes? So if you notice, we have one stripe out of 8 total sections. 1, 2, 3, 4, 5, 6, 7, 8. So the probability is 1/8. The theoretical probability. What is the theoretical probability of spinning a section with stars? So we have 2 sections with stars out of 8, and we have to simplify that, which would be 1/4. Good. What is the theoretical probability of not spinning a solid or a stripe? So no solids, no stripes. So we want the stars and the polka dots. So that's 1, 2, 3 out of 8. So that's what should happen. In theory, that's what should happen. So now what we're going to do is we're going to perform an experiment. And we're going to use this spinner and spin it 10 times and complete the table below. Okay, so to do that, what I'm going to do is I'm going to use this handy dandy paper clip. I'm going to put my pencil here and I'm going to spin it time 1. And that landed on a star. So star gets 1 tally. Okay, so I'm going to do spin 2. And that, we'll call that polka dots or dots, so that gets a tally. So I'm going to spin it again. And that's solid or white. That's spin 3. So you see how I'm actually doing it? I'm performing an experiment. That's experimental probability. Spin 4 is white. Spin 5. That's in between, so we'll do that over. Spin 5 is stripes. Spin 6 is, if you can see that, stars. It was on stars. Spin 7 is stripes. Spin 8, oops, I think I flicked that off the paper. Try it again. Spin 8 is in the middle, so I'm going to do it over. So that's stars. Spin 9 is stars. And spin 10, that's in the middle, so we're going to do it over. That's in the middle. That's mostly on stripes. Okay. So stripes, the probability of getting stripes was I actually got 3 out of 10. So my theoretical or experimental probability is 3/10. White is 2 out of 10, or 1/5, because we have to simplify. dots were 1 out of 10. And stars were 4 out of 10. Or 2/5. So if you look at this, which one did I get the most of? I got mostly stars, right? But if you look at your spinner, what should I have gotten mostly of? What is this mostly made up of? What is the spinner mostly made up of? It's mostly made out of solids or whites, right? So in theory, I should have gotten more solids, but what really happened was I got more stars. That's the difference between theoretical and experimental probability. Okay, on the back of your page, relative frequency is the total number of successful attempts divided by the total number of trials. It can be used to make predictions. So it's the number of successful attempts divided by the total number of trials. So in this one, they have a spinner, and they spun it 50 times. The results are shown in the table below. They want us to complete the experiment. So before we do an experiment, I want to go over it. So when the number 1, when they spun it 50 times, they got 12. So that would be 12. That was the number of successful attempts over 50, which when you simplify that is 6/25. So 2, they spun 2 8 times. So that was 8 out of what? 8 out of what? 50. Good. And then simplify it. So simplify it in your calculator and tell me what you get. 4/25. Good. When they spun 3, they landed on it 13 times out of 50. And that is simplified. The number 4, they landed on it 10 times, 10 out of 50, which simplifies to what? 1/5, good. And the number 5, they landed on it 7 times, so that is 7 out of 50. Now what they want us to do is spin this 100 times. Well, I'm not going to do that because that would take forever, but I'm going to use a computer to help me. Okay, so if you notice on the screen, I have a spinner that has 5 sections on it. We're going to let blue be number 1, pink 2, gray 3, orange 4, and green 5. So it's going to go 1, 2, 3, 4, 5. So I have 5 sections, and I want to spin it 100 times because that's what my experiment says. So I'm going to go ahead and do that. So when I click spin here, it's going to go through spinning it 100 times. So if you look over here, this is what happened when I spun it 100 times. So blue is number 1. So we landed on 1 48 times. So when you go back to this paper, when we spun it through our experiment, we landed on there 48 times out of 100. So in your calculator, when you figure out what 48 over 100 is, simplified, we get 12 out of 25. And actually, let's just put 48 right here. All right, let's go back to our screen. And it landed on pink 44 times, so that'd be 2. So 2 is 44 times. So number 2 was pink. We landed on that 44 times. 3 we said was gray. So 3 is 37 times. For 4, we said orange was 4, so that's 45 times. And for 5, we said green was 5, and we landed on that 26 times. So now let's figure out our relative frequency. So this would be 44 over 100. So when you put that in your calculator, remember this is our successful attempts over how many we did. So we landed on 2 44 times out of 100. So we're going to do 44 ABC 100, and we get 11 over 25. We're going to do 37 over 100. That's in simplest form already. 45 over 100 is 9 over 20. And 26 over 100 is 13 over 50. So when we did this experiment, you can tell it changed a little bit between 50 and 100. The more you do it, the more closer it should be to your theoretical probability. So the more we do it, the more it should be close to 20%. So that's what we're going to do next. So on the spinner for number 5, it says, what is the theoretical probability of spinning each of the numbers? To spin a 1, it would be 1 out of 5, right? Which is 20%. 3 would be 1 out of 5, which is 20%. 5 would be 1 out of 5, which is 20%. 2 is 1 out of 5, which is 20%. And 4 is 1 out of 5, which is 20%. So for number 6, it says, how does the relative frequency change between when the spinner is spun 50 times versus 100 times? And the answer to this is the number of trials increases. So the more you do it, the closer you get to theoretical probability. So the more I do it, the more my answer should be close to 20%. The less you do it, the farther away they get. Okay, so number 7 says, suppose the spinner is spun 1,000 times. Predict the relative frequency of each spin. So is 1,000 more than 50? Yeah. Is it more than 100? So because I'm spinning it so many times, my relative frequency should be what? It should be the same as my theoretical. So it should be 1 out of 5, 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 which these are all 20%. So the more you do it, and 1,000 is a lot, so those should be really close to 20%. Okay, number 8 says, create a spinner that has a 50% theoretical probability of spinning a 3. So 50% is the same as half. So I'm going to do a spinner, and I want 50% of it, or half of it, to have a 3. So if I spin it, I have a 50% chance of landing on a 3. We can make the rest of this anything else we want. Let's make this 1, 2, and 4. So half of my spinner is a 3. The other way you could do it is just like this. You could do 3 and 1. So 50% is 1 out of 2. So you could do a spinner that way. Create a spinner that has a 20% theoretical probability of spinning on an odd number. So 20% is 1 out of 5. So we want a spinner where 1 out of 5 is going to be odd. So here's my spinner. Let's break this up into, it's supposed to be 5 equal parts, so I'm going to get as close to that as I can. And if you look back at the spinner here, that's 5, so you want to kind of break it up that way. So I'm going to do it kind of like this. So I have 1, 2, 3, 4, 5. I want one of them to be odd. So I'm going to make this a 1, 2, 4, 6, 8. So to spin on this, I have a 1 in 5 chance to get an odd number. That's what 20% is. So what about 10? What would 10 be? It says create a spinner that has a 25% theoretical probability of spinning a 4 or 7. So 25% is 25 over 100. When you simplify that, it's 1 out of 4. So you want a 1 out of 4 chance a spinning of 4 or a 7. So 1 out of 4